Hey, Math 3 Honors. How's it going? Guess what we're going to learn today? We're going to learn how to graph tangent. We know how to graph sine. We know how to graph cosine. What the heck? How the heck do you graph tangent? What is tangent equal to? How can we use this to graph it? The unit circle. Remember, the radius is 1. So, anyway, we're going to be practicing by comparing sine and cosine together and looking at them to with tangent. There's a relationship there. A relationship. It's a beautiful relationship. What happens if you put sine and cosine together? How can you put sine and cosine together? Where does tangent fit in all this? I don't know. No, I do. I know. All right. So let's go ahead and get it started. Find my camera. You will need graph paper for this. You might want to use a ruler. Yeah. And go outside and go for a run or something. You know, get up before 3 p.m. Get some exercise. Get stronger. Get strong. Get fit. That's what you're going to do. Okay. Let's get busy. Let's get busy. Busy. Hair's messed up. I really need a haircut. It's been a really long time since I got my haircut. I'm starting to call places to see if they're open. I'm just calling. Hey. No. I'm shaving at least. I know a lot of people not shaving. It looks good, but I'm not going to follow that trend. I'll shave. I'll grow a beard when everyone else is not growing a beard. All right. Let's get to work. Okay. So we're going to learn how to graph tangent. Now, let's see here. In order to graph tangent, let's review sine and cosine and see how they relate. Now, I'm going to write here, I forgot to write it, SOHCAHTOA. You already know it, but let's just put it there for, so that we can have a visual understanding. Sorry, this handwriting's so bad. So I have here 6 triangles. I was going to do a 30-degree angle triangle, but you can see the red I want to get sine, the purple I want to get cosine, and then the orange I'm going to see tangent. Now the point of this is we're going to learn how to graph tangent. Okay, but we have to see what is the relationship of tangent of sine and cosine. Now for all of these we have a hypotenuse of 1 which represents our radius in the unit circle of 1. So what is the sine of 30? Now remember, sine is opposite over hypotenuse. If I take this, okay, the sine will be the opposite, which will be here. And remember, in a 30, 60, 90, this will be 1/2. And so the sine of 30 is equal to opposite over hypotenuse, which is 1/2 divided by 1, which is just 1/2. And we already know that. Sine of 30 is 1/2. What about the cosine of 30? Now remember, the cosine is going to go over here. So get the cosine. Let's get the length of this using a 30, 60, 90 triangle. This will be 1/2. So then this side will be square root 3 over 2. So the cosine of 30 is equal to adjacent over hypotenuse, which is root 3 over 2 divided by 1, which is root 3 over 2. So the cosine is square root 3 over 2. Now, let's look at the tangent. This is going to get interesting. Now, we already know, based on our 30, 60, 90 triangle, that this is going to be 1/2. The opposite of my 30 is going to be 1/2. Opposite of my 60 is going to be square root 3 over 2. Okay? So what is the tangent of 30? The tangent of 30 is going to equal, tangent is opposite over adjacent, which is 1/2 divided by root 3 over 2. Now, let's actually work that out. What does that equal? So we have 1/2 divided by 1/2 divided by root 3 over 2. And remember, when we divide fractions, 1/2 is divided by root 3 over 2. Or we multiply by the reciprocal, 1/2. This is a quick review, times 2 divided by root 3, which is equal to, these cancel out, right? And it's 1 over root 3. I can't have root 3 as the denominator, so I multiply, right? I can't have square root of 3 in the denominator, so I can multiply by root 3, but I also multiply the numerator times root 3. Root 3 times root 3, I'll do the steps for those of you who are not knowing what's going on. Root 3 times root 3 is root 9. 1 times root 3 is root 3. And square root of 9 is 3. So it's root 3 over 3. Now after all that, well, root 3 over 3 is tangent of 30. We'll just leave that like that for now. Okay, I'll see if we see it. There's a fundamental thing that you must understand here, and I'll talk about that in just a second. Let's do the sine of 45. Sine of 45. Now, remember, on a 45, 45, 90 triangle, I divide this by square root of 2, which ends up being root 2 over 2. So sine of 45 is opposite over hypotenuse. This is root 2 over 2 divided by 2, which is root 2 over 2. We already have that in the unit circle. We know that sine of 45 is root 2 over 2. Sine of 45 here, well, this is root 2 over 2, and this is also, remember, root 2 over, it's an equilateral, a isosceles right triangle. Anyway, cosine of 45, the cosine of 45 is adjacent over hypotenuse, which is equal to root 2 over 2 divided by 1, which is cosine of 45 is root 2 over 2. So we got that. Now, what about the tangent of 45? Well, the tangent of 45 is, well, this side's root 2 over 2, this is root 2 over 2, is equal to, tangent is equal to opposite over adjacent, so it's root 2 over 2 over root 2 over 2. Well, what is root 2 over 2 divided by root 2 over 2? See, this is a fraction. Now they're both the same. Well, you can just say tan 45. Anytime you have the numerator equal to the denominator, what does that equal to? That equals to 1. Okay, after all that, the main thing that I need you to recognize is this. Tangent is really equal to 1/2. What is 1/2? Sine over root 3 over 2. What's root 3 over 2? Cosine. And the same thing here, which is here, tangent 45 is root 2 over 2. What's root 2 over 2? Sine is root 2 over 2 over what? Root 2 over 2. Cosine 45 is root 2 over 2. So after all that, the main thing I want you to get out of this is this. After all that is tangent of x is equal to sine over cosine. Tangent of x is equal to sine of x over cosine of x. Write that down. You must know that tangent of x is equal to sine of x over cosine of x. Okay, so let's go ahead and graph tangent of x based on that information, we can now use the unit circle. Tangent of x is equal to sine over x divided by cosine of x. Okay, so now let's graph this using our four scenarios, our four representations of a function, okay? So here's a quick, you can pause it if you want here. I'll try to get a better view of that, okay? Zoom in a bit more, but go ahead and pause it and copy that. Now I have here, we're going to do a situation, which is just the unit circle. Then we'll do a table. The table helps graph the graph, and then we have the equation here. Okay, here's a better picture of the graph. Okay, so pause that as you go, and pause that so you can copy that down at your convenience. But anyway, the situation is going to be the unit circle. We already have, I'm going to grab my unit circle that we filled out here. Now, the best way to graph tangent is by using, like, the matrix, the ones and the zeros. Binary code. I mean, not really, but what I mean by that is we're going to do trust me, we're going to do the 45-degree marks. 45 here, 45 here, 45 here, 45. Why 45? Or in radians, it'll be pi over 4. Because that's where the opposite and adjacent of the right triangle are congruent. Pi over 2, root 2 over 2 over 2. Negative root 2 over 2, negative root 2 over 2, root 2 over 2, negative root 2 over 2, root 2 over 2, right? Root 2 over 2, negative root 2 over 2, okay? So, anyway, we're going to use those, okay, to graph it. And I already have them pre-labeled here. This will be like our 45 marks. Now, I'll show you why that's going to make our life a heck of a lot easier. So, let's go ahead and graph 0. Key thing. Remember that tangent is sine over cosine, right? So here we go. And remember this also, cosine is the x, the sine is the y. Okay, so let's look here. What is the tangent of 0 degrees? Well, it is sine over cosine. I'll do a little thing right here. Tan of 0 degrees is equal to sine, what's my sine? 1 over cosine, 0. Sorry, did that wrong. Whoops. Tan of 0 degrees is equal to sine 0 over cosine 1. Sorry about that. So guess what? Tan of 0 degrees, what's 0 divided by 1? 0. Okay, so let's go ahead. Tan of 0 degrees is 0. So let's go ahead and plot that, or let's write it here on our little thing here. Tan of 0 is 0. Sorry, I didn't say degrees. We're doing in radians. We'll do radians. Next is pi over 4. What is tan of pi over 4? Well, tan, let's write it here. Tan of pi over 4 is equal to, tan is sine, which is root 2 over 2, over cosine, root 2 over 2. And, right, just real quick, those of you who are confused, let me just ask, let's do Godzilla time for 1 second here. What is 3 over 3 equal to? Well, it's equal to 1. What's 5 over 5 equal to? Well, that's equal to 1. What's 153 over 153 equal to? Well, that's equal to 1. Idea, if we have the same numerator and denominator equal, it equals 1. When numerator and denominator are both equal, so guess what? Tan of pi over 4 is equal to 1. Okay, so we have here tan pi over 4 is equal to 1. What about pi over 2? What is tan pi over 2? Well, let's look here. Here's my pi over 2. Tan of pi over 2 is equal to sine 1 over cosine 0. Now, got a question for you. Can I divide by 0? No. No, that is no solution. No solution. So guess what? Pi over 2 is no solution. We have no solution for that. Okay. What about 3 pi over 4? Okay, well, tan of 3 pi over 4 radians equals sine, which is root 2 over 2, divided by negative root 2 over 2. Now, they're going to be equal to 1, but since one of them is a negative, guess what? Tan of 3 pi over 4 is equal to negative 1. Tan of 3 pi over 4, since it's the same, but one of them is negative, that'll be negative 1. Simple enough. What about pi? What is tan of pi equal to? Tan of pi is equal to sine 0 over cosine negative 1. 0 divided by negative 1, well, that's just tan of pi radians is just equal. Anytime the denominator is 0, it's just going to be 0. So tan of pi is equal to 0. How about 5 pi over 4? Okay, well, let's look at tan of 5 pi over... Try this one on your own. Pause the video and see if you can figure out tan of 5 pi over 4. Here I am, 5 pi over 4. Whoops, so you can see that. Sine over cosine. Negative root 2 over 2 over root 2 over 2. Well, oh, sorry. Negative root sine. Negative root 2 over 2 divided by negative root 2 over 2. And when you divide two negatives, what do you get? You get a positive 1. So tan of 5 pi over 4 is equal to 1. Now what about 3 pi over 2? Well, here we are here again. Tan of 3 pi over 2 is equal to sine, negative 1 over cosine, 0. Cannot divide by 0, so that is no solution again. No solution because I cannot divide by 0. So that's no solution. 7 pi over 4. 7 pi over 4. Tan of 7 pi over 4 is equal to, remember 7 pi over 4, sine over cosine. Negative root 2 over 2 divided by root 2 over 2. Sorry, it's right there. Negative root 2 over 2 over 2 over 2. Root 2 over 2. Same, except 1's a negative. So tan of 7 pi over 4 is equal to negative 1. Negative 1. Okay, so I think we get the idea here. Tan of 2 pi is going to be the same as 360 degrees. That'll be 0. Okay? So far, so good. We just filled out the table. Hey, sorry, I want to take a little bit of a break. If you just want to keep trashing through, you can go fast forward through my little distraction here, like just in class, go through distraction, you just tune out or just fast forward it. But I got a question. I just have a question for all you guys. The other day I was shopping with my wife I was at Trader Joe's and I was wearing a mask. You know, just trying to be safe, wearing a mask. And I had to sneeze with my mask on. So as I'm about to feel that tickle in my nose, I'm thinking to myself, okay, I have two options here. I can sneeze right in the mask. Right? I think that's the whole point of the mask, right? So you won't spread germs. Or I could just take the mask off and do that, right? Sneeze in my... I did not want to sneeze inside the mask. I don't know. Is that bad? I guess it kind of is bad. Like, imagine you sneeze and you have all that stuff still there in your mask. And then you're walking around the whole store with all that. That's the only mask that I had. And we walking around with, you know, mucus or snot in my mask as I'm just like, people will see it. You can see it, can't you? It's like, well, what's that stuff? That's gross. Guy, what are you doing there? So you know what I did? I took my mask off in the middle of Trader Joe's and I sneezed. People were giving me looks. I understand it. I get it. I shouldn't have done that. But I didn't. I mean, what would you do? You can leave comments. Would you sneeze in the mask? Or would you just let it go? I mean, right? Supposedly, the germs can't go past 6 feet, so as long as no one's around me. So you can just run it outside and sneeze and fly in a trash can or something. Fly, and then put the mask. I was not going to sneeze in the mask. I did not want to sneeze in the mask. Is that bad? Let me know. I don't know. It was a tough one. These are tough times, man. You tell me what you would do. Let's get back to work. Okay. Let's go ahead and graph this. Now, I know what you're thinking. Sensei, well, what about the no solution? Some of you know. What does that mean when you graph and you have something that is no solution? What does that mean? At pi over 2 radians and 3 pi over 2 radians. You know it as I'm doing it. What is it? Oh yeah, baby. You got yourself a nice, and 3 pi over 2. What goes to 3 pi over 2? A nice little asymptote. And what happens at asymptotes? It just gets right. It has to go up to that asymptote. It goes up to it, but it never ever touches it. Okay, so based on that information, let's go ahead and graph tangent here. At 0 radians. Come here. 0 radians, we got 0 degrees. 0 radians, we have 0 degrees. At pi over 4 radians, I got 1. So I go up here at 1. Now, after pi over 4, I have pi over 2. I have no solution. So this is what's going to happen. They're going to go here, here to here. And then it's going to go to this point, right? It has to go, it has to keep going. But it's going to keep going, and it cannot touch the asymptote. So it's going to hug that asymptote and just look like that. 3 pi over 4, what's that? We're at now -1. Right here, -1. Pi, we're at 0. And 5 pi over 4, we're at 1. So, look at that. What is that going to look like now? Well, it's not going to be it can't be a line like that, because remember, it has to hug this asymptote here. It has to get close to the asymptote. This will go here, and then it'll go to this point, and then it has to go to that point, and then that point, and then guess what? It's going to hug this asymptote here. So it'll look like that. And that's what happens at 3 pi over 2 is our asymptote. What about pi? Oops, hang on here. Not pi. 3 pi over 2. What about 7 pi over 4? Well, we're now at 7 pi over 4 is -1. And then 2 pi is 0. So guess what? Has to hug this asymptote and go up here. And it's going to keep doing that. It's going to keep repeating. So essentially, it'll look like this. And this will look like this. Okay? That is what y equals. There's our graph. Here's our equation. That's what y equals tangent of x looks like. Okay, so go ahead and, you know what? Punch that in your Desmos and see what happens. Okay, but that is what tangent of x equals. And that is how you graph tangent of x. And that's it. We just graphed y equals tangent of x. And we talked about sneezing during the coronavirus. How the heck do you do that? Or how do you sneeze during the coronavirus? I don't know. Okay, I feel fine. I don't think I'm sick anyway, but, you know. So, I don't think I have anything else to teach you guys. We're just getting a lot done so far. Oh, by the way, I'll talk to you about it at school, but I heard that school's going to end June 5th this year. June 5th, so we have 1 month left of watching my videos. Okay? This is the Smiths. Hopefully they won't delete the song on the YouTube channel. Okay. This is Sensei signing off. Take care. Napoleon Dynamite. Hasta la vista.